Now we're asked to find the derivatives of some more challenging functions because this and this are not written out as polynomials. So maybe the first step we'd like to take is to write this out as a polynomial. I'm going to distribute this 3x to both of the terms of the binomial in parentheses, and I'll get 3x minus 15x squared. You can see that your success in calculus is going to depend heavily on your ability to do simple algebra. Now, I've got 3x to the first, multiply and subtract. 3x to the 0 is just 3, minus multiply and subtract. This will give us 30x to the first, which is 30x. Here, let's expand this binomial to give us 2x plus 1 times 2x plus 1. Again, algebra skills are going to be super important in calculus. As we FOIL this, we get f of x is equal to 4x squared plus 4x plus 1. Now, and only now, at this point, we'll say we can take the derivative. 2 times 4 is 8x to the first plus 4x to the 0 plus a constant has a derivative of 0. So there is our derivative. Here, we're going to deal with negative exponents for the first time. Maybe this was originally 6 over x to the 9th. We move that up, and now we can do multiply and subtract. Negative 54x. Now, why negative? Because negative 9 times positive 6 is negative 54. X to the negative 9 minus 1. Now, why do I write that out? Because this is the first time we see it. We've just got to be careful that we're going to have negative 10 there. And in our last one here, we've got a fractional exponent. Maybe this was written as 5 over x cubed, but we've got a square root. So maybe it was that originally, and we converted it to this so we could take the derivative. Negative 3 over 2 times 5 is negative 15 over 2, or negative 7.5. X to that negative 3 over 2 minus 1. And look, I'm doing multiply and subtract. But this doesn't really help me if I put it as minus 1. I'm going to make that into a form that's compatible with my denominator. So I'll make that 2 over 2 to give us negative 15 over 2. X to that, well, negative 3 over 2 minus 2 over 2 is negative 5 over 2. And of course, we could convert that back to something like this, but I'd like it to leave it there because what if we're asked to find the, wait for it, second derivative? That would be a good form to have our answer in. Here we've got some more challenges to our ability to use the power rule to find the derivative. Remember from algebra, if we have a plus b over c, in other words, two terms over a single denominator, we can divide that denominator into both. So this is a over c plus b over c. So when I see a problem like this is how I approach it personally. I say, well, I've got this single denominator and I'll divide it into both to give me 4x cubed over x minus 2x squared over x. Now, remember, if we have a to the m over, x to the m over x to the n, we'll get x to the m minus n. Exponent of the numerator minus exponent of the denominator. So this means we have 4x to the 3 minus 1 minus 2x to the squared minus 1 to give us 4x squared minus 2x. That's f of x. So f dash of x would be multiply and subtract. 8x to the 2 minus 1 is 1. And here is minus 2, x to the 1 minus 1 is x to the 0. Again, I don't write that x to the 0. I know that the derivative of any linear term is simply the coefficient. So I get the correct answer, 8x minus 2. Now that we're maturing in our ability to do math problems, we've gone through Algebra 1, Algebra 2, pre-calculus. Of course, you could have instead of dividing that single denominator into each and every term of the numerator, remember, when I say term, terms are separated by pluses or minuses, so one term, two term. I could have also approached this by factoring out the common factor. If I factored out x from the numerator, I could have even gotten more greedy, right? If I factored out x squared, say, we'd have 4x minus 2 over x, and then I could have canceled one of these to give me x times 4x minus 2. distribute, I get 4x squared minus 2x, and then the derivative of that, I could have written this as dy dx, or y prime, or f prime of x, f dash of x, still would be 8x minus 2. Multiply and subtract, multiply and subtract. Either way, I get to 8x minus 2. For our last problem down here, look at the situation. Much better to write this monomial as 8x to the, well, this is an index of 2 and a power of 1. So that's to the 1/2. Our derivative, f dash of x, will be multiply 8 times 1/2 x to the 1/2 minus 1. And I'm going to write this 1. I'm going to be really sneaky. I'm going to write it in a compatible form with that fraction to give us 4x to the 1/2 minus 2 over 2 is negative 1/2. Now, that's a fine answer. I actually prefer to leave my answers like that because if I'm asked to take the second derivative, I can easily take the derivative of the derivative. But of course, this is the same as 4. This is 4 to the first power, so it stays up in the numerator. And this is x to the 1/2, which we know is the square root. And if you wanted to rationalize that, you could too by multiplying by root x over root x. Here are some more power rule problems where we're asked to find the derivative. So we want to put this function in the form that allows us to find the derivative. This will be x to the power over root 1/3 minus x to the power over root. Notice I took the function from radical form into fractional exponent form so that f dash of x or f prime of x or dy dx or y prime could be found easily. Multiply and subtract. 1/3 times 1 is 1/3 x to the 1/3 minus 1 minus, well, this is 1 times 3/4 is 3 over 4 x to the 3 over 4 minus 1. Now I'm going to make this one into something that's compatible with that fraction and this one into a fraction that's compatible with that fraction. So I'll get 1/3 x to the negative 2/3 minus 3 over 4 x to the negative 1/4. And that's a fine answer. Now, if you wanted to go above and beyond, you could say that this is 1 over 3. Now, x to the 2/3 would be the third root of x squared minus 3 over 4. And this is the fourth root of x, so the fourth root of x. And then, of course, you could rationalize those. But if you're asked to find the second derivative, maybe this form, well, certainly this form with the fractional exponents is more compatible or more to our liking. If we're asked to find the derivative here, first I want to write this function as, well, this is 3 to the first power, 3x to the negative 5. Now that it's written, this monomial is written in this form, I can multiply and subtract. Negative 5 times 3 is negative 15x to the negative 5 minus 1 is actually negative 6. Now, I like this form. I like this form, even though it has a negative exponent. Of course, this is equal to negative 15 over x to the positive 6. But this is a fine answer. And look, I actually like this one a little better right here.